Good morning everyone. In this video, we will see the expression for wavelength of an electron on the basis of de Broglie hypothesis. In de Broglie hypothesis, he describes that the whole energy in the universe is in the form of electromagnetic radiation and matter. Second point is nature loves symmetry, therefore electromagnetic radiation and matter must be symmetrical. Or in simple language, we can say that as the electromagnetic radiation has a dual nature, wave nature as well as the particle nature, matter also has a dual nature, that is wave nature as well as the particle nature. Okay, let us find out the expression for wavelength of an electron. Consider a particle of mass m and its kinetic energy is Ek. Ek means kinetic energy. Then you know that the kinetic energy Ek is equal to the 1/2 mv square, where v is the velocity of that particle. Okay. Then what is the value of v square from this equation? V square is equal to the twice Ek upon m. Okay. Therefore, V is equal to the under root of twice Ek upon m. Okay. Just we have find out the wavelength of a matter waves. That wavelength of matter waves is lambda is equal to the h upon mv. Okay, then put the value of v here. Then what we get? Lambda is equal to the h upon m, as it is. V is under root of twice Ek upon m. Okay, now next step. Lambda is equal to the h upon, take this m inside the square root, therefore it becomes the m square. Okay, then this m square upon m, it get 1 m get cancelled, therefore we get here h upon m into m upon this under root of m upon twice E into K. Therefore, lambda is equal to the h upon under root of twice m into E K. Okay. Therefore, if this is in the under root, inside the under root, then this becomes m square. Therefore, m upon m square, this m get cancelled. Therefore, here is remaining only the m. H as it is, where h is the Planck's constant, m is the mass of that particle and Ek is the kinetic energy. Now consider an electron of mass m, charge E, which is accelerated through a potential difference V. Then what is its work done? Work done is equal to the E into V, and this work done provides the kinetic energy, therefore which is equal to the Ek. Okay. This is the kinetic energy of an electron. Therefore, we get lambda is equal to the h upon under root of 2 m into E into V. Okay. where h is the Planck's constant, m is mass of electron, E is the charge on electrons, and V is the potential difference. Put all this substitution, if you put the value of h, what is the h? H is the Planck's constant. Put this value, it becomes 6.63 into 10 raised to minus 34 joule second. M is mass of electron, it becomes 9.1 into 10 raised to minus 31 kg. Okay, then E is equal to the charge on electron, it is 1.6 into 10 raised to minus 19 coulomb. Okay, then we get here lambda is equal to the 1.228 upon under root of V into 10 raised to minus 9 in meter. Therefore, this is the value of wavelength of an electron on the basis of de Broglie hypothesis. Okay? This is again the equation of or relation for the wavelength of an electron on the basis of de Broglie hypothesis. Here we have simplified again and we have obtained the simple form lambda is equal to the 1.228 into 10 raised to minus 9 upon root V in meter. Also you can calculate in Armstrong. Armstrong मध्ये म्हटल्यानंतर काय येईल 12.28 upon root V in terms of Armstrong. In terms of nanometer 1.228 upon root V, it is in the terms of a nanometer also. Okay, you can find out the wavelength of an electron for any accelerating potential. Okay, therefore this equation is important. Okay, then next point is wave particle duality of matter. In previous video, we have explained wave particle duality of radiation, electromagnetic radiations. Now, wave particle duality of matters. These material particles shows the wave nature under certain condition. Material particle shows wave nature under some condition. This is called as wave particle duality of matter. Therefore, matter behaves as a wave. According to the classical theories, frequency omega and wave number k are used to describe the waves, and momentum p and energy E are used to describe the particles. In classical mechanics or in classical theories, frequency omega and wave number k is used to describe the waves, and momentum and energy is used to describe the particles. Okay, this is the second point. And third point is related to the, of course, this is Wave-particle duality implies that all moving particles have an associated frequency and associated wave number. All moving particles have associated frequency omega and wave number k. Okay, and all waves has momentum p and energy E. Okay, therefore all moving particles can have associated frequency and associated wave number. Also, all the waves have associated momentum and associated energy. This is about the wave particle duality of a matter. Okay, this is the last point of this chapter, dual nature of electromagnetic radiation and matter, की जेणे त्याने आपण या चॅप्टरचा एंड केलेला आहे की वेव पार्टिकल ड्युअलिटी ऑफ मॅटर. आणि बिफोर व्हिडिओ वी कॅन सी द wave particle duality of electromagnetic radiations. Okay, let us take one example depending on this equation. Lambda is equal to the 1.228 into 10 raised to minus 9 meter upon root V. Okay, then example is problem. Calculate wavelength of an electron accelerated through a potential difference of 25,000 volt. Okay, let us solve this problem. Calculate wavelength of an electron accelerating through a potential difference of 25,000 volt. Okay, therefore we have given here data, solution. Okay, V is equal to the 25,000 volt. Okay, and we have to calculate the wavelength of an electron. Therefore, we have to calculate lambda. Okay, therefore use the formula. Lambda is equal to the 1.228 into 10 raised to minus 9 upon root V. Okay, therefore lambda is equal to the 1.228 into 10 raised to minus 9 upon root V is under root of 25,000. Okay, therefore lambda is equal to the 1.228 upon 25,000. Root of 25,000 is, let us see, this is 158.11, and if you calculate this, it becomes 0.0077 into 10 raised to minus 9 in meter. This is the answer of wavelength of an electron, 0.0077 into 10 raised to minus 9 meter. Let us stop here.